This is a lesson for Algebra 2, adding and subtracting polynomials. The objective for this lesson is students will add and subtract polynomials of higher degree. Recall a monomial is anything with one single term, so we could have x as a monomial, we could have x squared as a monomial by itself, you could even have a large one that says 31x to the 15th power is also a monomial. There's nothing being added and subtracted to it. A binomial has something subtracted or added to it, so we could have x plus 1, you could have another example is x squared plus 2x. There's a variety of them. Trinomial, prefix of tri, there's 3, so it's going to be, an example could be x squared plus 2x minus 1. That's an example of a trinomial. So it has 3 terms in it. So this is a review from algebra, but these are monomial, binomial, and trinomial. Trinomial and anything with 3 or more I call a polynomial at that point. Polynomial steps: identify all coefficients first. Then you want to reorganize all the terms. Reorganize all the terms in descending order. So we think about what's the biggest exponent first, and then we organize them into descending steps. Then we distribute any negative signs that we need to. After you reorganize all the terms, combine like terms at the end and simplify your answer in descending order, making the largest exponent up in the front. Continuing forward here. So we're going to add some binomials in these first examples. For example 1, first thing you want to do is ask yourself, what's the largest exponent? Well, there's a to the third here and a to the third here. They seem to be up in the front already, and we want to put the largest exponent up in the front. The coefficients for these is positive 1 is here, and there's a positive 1 here. When we begin, we put positive 1, a to the third power, for our first binomial. Then we ask ourselves, are there any other terms in this binomial we need to bring down? Yeah, there's a minus 2 here. Then we ask ourselves, what is the operation that's here? It's a plus sign. Bring down a plus sign, and we're going to open parentheses to put the second binomial in. Since it says a to the third right here, we want to have any a to the thirds underneath that might be existing in the second binomial. As you can see right here, it says a to the third, and it's positive a to the third, so we'll put positive 1 a to the third. And we have a constant here of negative 2. We check if there's any constants. There is right here. You bring down a minus 3. We do a vertical problem. Starting from the left, we have 1a to the third plus 1a to the third. That's going to be 2a to the thirds. Then we have negative 2 plus a negative 3. So negative 2 plus a negative 3 is going to be a negative 5. So we put minus 5. It's good to say positive or negative, whatever it is, when you are working with these polynomials, so that you know what operation you need to put for the actual answer. That's number 1. Let's try. For number 2, we have 2 different types of terms, n to the fourth and n to the second. Again, start with the first term. Our first binomial with the largest exponent, so it's 2n to the fourth. So I'm going to bring that down first, 2n to the fourth, and bring down any other exponent. We have n to the second right next to it. There are no n to the third, so we don't have to put that into this example. Then we ask ourselves, what's the operation? Put the operation on the outside. Open parentheses. We have n to the fourth in the first term, so we need to find n to the fourth to put here. We know that there's n to the fourth right here, so we want to bring that down just underneath it. Then we ask ourselves, are there any other n to the seconds in our second binomial? Yes, there's a negative 3n to the second. Write it across. 2n to the fourth plus 3n to the fourth is 5n to the fourth. Negative n squared plus negative 3n squared is going to be negative 4n squared. The reason for that is because there's a negative 1 here. So it's like saying negative 1 plus a negative 3 is negative 4. Then we make sure that we could simplify if we can. Then we will. But we don't have anything else to simplify, so we box our answer. Continuing on here. Let's jump to example 4. Example 4 is really important because there's more than one term. So in this whole problem, we need to see what's the largest term that's here. Right here, we find that p to the 4th is the largest. There's a p to the 4th here, and there's a p to the 4th here. We also see that there's a p to the 3rd here, but there's no, and there's a p to the 3rd here. So we're good there. There's a p squared here, but there's no p squared anywhere in this first binomial, so we'll have to make space for that, and I'll show you how to do that. And then there's a p to the 1st here, but there's no p to the 1st here, so we'll have to make space for that when we write out our problem. So the first step, identify all of the coefficients. So we have a positive 5, negative 4, negative 3, positive 5, positive 2, and this should be positive 1, right? So since we have all our coefficients, now we could start with the first binomial. Starting with the largest exponent, we have 5p to the 4th power. Start with that. Next exponent that's smaller is p to the 3rd. We have negative 3p to the 3rd we could bring down, so we bring down negative 3p to the 3rd next to it. Next exponent down is going to be p to the 2nd. There is no p to the 2nd here, but there will be a p to the 2nd right here. Since there's a p to the 2nd right underneath, or right in the beginning of the second trinomial, we need to make space for it. We don't have any p to the 2nds in the first trinomial, so we're going to just pretend that there are 0 p to the 2nds, just so we could put a placeholder. It does not affect the value if we add 0 of anything to this trinomial. Then we know that the next exponent is p to the 1st, so we have minus 4p, and there are no constants in this problem, so I'm not going to worry about adding any constants. Then I look at my operation, which is a plus sign, open parentheses. Now that we have them organized in the first line, it'll be very easy to organize the second line. While focusing on the second trinomial, let's look at what we could put on the second line. So 5p to the 4th is here. We're looking for p to the 4th. We have a p to the 4th here, and this is really like 1p to the 4th. So since it's 1p to the 4th, we're going to bring 1p to the 4th down underneath it. Then we're looking for p to the 3rds. In my second trinomial, we have 2p to the 3rds here, so we'll bring down a plus 2 p to the 3rds underneath it. Then we're looking for p squareds. We have 5p squareds right here, so we could put down positive 5p squareds here. Remember, we want to identify the coefficients at the beginning. We know that was a 5, and that's logically a positive 5. And then we look for p to the 1st. Now, over here we don't have any p to the 1sts, but in the original trinomial, we did have p to the 1st right here. And so what we need to do is add a marker, 0p, because the second trinomial doesn't contain one. Close parentheses, there's nothing else to add. Now we've included all our terms. Draw a line across, and we begin adding. So we have 5p to the 4th plus 1p to the 4th, which is going to be 6p to the 4th. Then we have negative 3p to the 3rd plus 2p to the 3rd, which is going to be negative 1p to the 3rd. Then we have 0p to the p squared plus 5p squared, which is going to be 5p squared. Lastly, we have negative 4p plus 0p is going to continue to be negative 4p. Now we could keep this the same way, or we could just erase this 1 that we had placed as a coefficient, because we know we could assume that it's going to be 6p to the 4th minus p cubed plus 5p squared minus 4p. There's your answer for this larger problem. Continuing on, we're going to look at subtracting now. Now subtracting is a little bit different. We have to be very careful with our signs. So I want to focus really on number 2 here, because number 2 could be a little tricky. So we start with looking at the largest exponent, and we know it's x to the third, and we also want to look at all of our coefficients. We know that the first one is positive 1, we have negative 3 here, then we have positive 6 here, this is a coefficient, and then we have negative 8 and 1 is a constant, and this is a positive 1 here, by the way. Okay? And this is positive 6. So we start with, sorry about that. We start with x to the thirds. Let's start with the first binomial. We have negative 3x to the thirds. Okay? Do we have any x squareds anywhere in my problem? No, so I don't want to include them. Do we have any x to the first? No, I don't want to include them. We have a positive 1 here I need to bring down. That's my constant. Okay? Now we're done with the first binomial. Now I ask myself, what is the operation I have here? I have a negative operation or a minus operation. So I put a minus sign this time. Open up parentheses. Looking at my second binomial now. Not at the first one anymore, just the second one. Okay? I'm looking for x cubes now. We have positive 6x cubed here. So we want to put positive 6x cubed underneath. Then we're looking at constants. We have negative 8 as a constant here. So we want to bring down negative 8 down here. Okay? This is where it gets a little bit tricky. So a good way to do this, you might distribute it across, or you might just, you're really good with your integers, but we have to think very carefully. So we have a negative 3x cubed minus a positive 6x cubed. When we put those three together, negative 3x cubed minus a positive 6x cubed, we get a negative 9x cubed. Now if that's confusing to you, you could just do a side problem. Just take the coefficients, negative 3, take the operation minus, and then take the second coefficient, work out a middle school problem. You know that negative and positive should be negative, so we have the same sides, negative 3 minus 6, which is really adding and keeping the sign, which could be negative 9. Okay, that's on the side. Then, look at the constants. We have positive 1 minus negative 8. Since we have a positive 1 minus a negative 8, we know that we're going to actually add 8 to this, so it's going to be 1 plus 8, which is 9. So it's going to be positive 9. Again, if you want to do a side problem, you're going to do positive 1 minus a negative 8. Circle the two negatives, it's a positive, so it's 1 plus 8 is 9. And that's it. So the negative subtraction signs need to be taken care of very carefully. I would recommend doing side problems like this. It's okay if you do junior high problems, because it's better that you're accurate than wrong, okay? So don't feel embarrassed. Once you get to do this a lot, you're going to be really good at it, and you won't need to do these side problems as much. And this will conclude our lesson for adding and subtracting polynomials.